Alright, hello everyone and welcome back to another video provided by SVSU's online tutoring. My name is Joel and today we'll be continuing on with section 8.6, quadratic and rational inequalities. And the topic this time will be rational inequalities. So, the main takeaway for this topic is the concept of critical numbers. So, critical number is any number where we have a 0 in the numerator or a 0 in the denominator, okay? So for instance, if I had x plus 4 divided by x minus 1 and x minus 3 greater than 0, what we want to look for are the critical numbers that will end up constructing our test intervals to see what values of x this inequality holds true. So all I have to see is that when I have x plus 4 in my numerator, I set that equal to 0 to solve for x, and I end up with x minus 4. And likewise, I do the same thing with my factorized quadratic guys right here. So I have x minus 1 equal to 0, which gives us x equal to 1, and x minus 3 equal to 0, which gives us x equal to 3. And so these three values of x here will be used to set up our test intervals. So from negative infinity to negative 4, that's one interval, and then we have negative 4 to 1, we have 1 to 3, and then we have 3 to positive infinity. And so from here, you would have to pick out 4 values that are within these intervals, and then plug them back into your original inequality to see if they're greater than 0. So let's start with a simpler example first. If we have x divided by x minus 3 greater than 0, what are our critical numbers? So in our numerator, x is only equal to 0 when x itself is 0, and in our denominator, the denominator is 0 when x is equal to positive 3. So if we construct our test interval, we'll go from negative infinity to 0, 0 to 3, and 3 to positive infinity. And so from here, if we pick, let's say, negative 1, 1, and 4, those will be the 3 values that we have to test. So we take each of those and plug them back into our inequality. So we have negative 1 divided by negative 1 minus 3. And so that's negative 1 divided by negative 4. Dividing two negatives makes the number positive. And so we end up with 1/4 being greater than 0, which is true. So then our next number is 1. So we go 1 divided by 1 minus 3. And we have negative 1/2, which is not greater than 0. And then finally for 4, we have 4 divided by 4 minus 3, which it gives us just 4, which is greater than 0. And so, since we're only good for 2 of our intervals, we can construct our solution set. So our solution set will run from negative infinity to 0 in union with 3 comma infinity. And so if you were to set this up on a number line, what it would look like is, so you have 0 right here, and you have 3 right here. Make sure to put just your parentheses because neither 0 or 3 are included. And then you just make sure that you emphasize that you're looking at the solutions that go in this direction, and then the solutions that go in this direction. Okay, if we scroll down here for another example. So if I have x minus 2 divided by, on the edge of my writing pad here, divided by x plus 2 times x minus 3 greater than 0, what would our critical numbers be? So we have x minus 2 equal to 0, we have x plus 2 equal to 0, and x minus 3 equal to 0. Each of these will give us our 3 critical numbers. So we see that one critical number for our numerator is x equal to 2, and then in our denominator it's negative 2, and then our second x value for our denominator is x equal to 3. So from these 3 x values we can set up our test intervals. So we go from negative infinity to negative 2, comma, negative 2 to 2, comma, 2 to 3, comma, and 3 to infinity. So it's pretty easy to pick some test intervals for this one, or you know, a test value for this one, and we could do negative 3. This one could be 0, and this one is 4. But for this one, you know, 2 to 3, it's not an integer step, so we have to go to a decimal place, and 2.5 is a simple enough one. Okay, so all we have to do now is just plug each of these 4 values into our inequality, one by one of course, to see if they're greater than 0. So if we start with negative 3, we have negative 3 minus 2 divided by negative 3 plus 2 times negative 3 minus 3. So in our numerator we have negative 5, and then in our denominator we'll have, this is negative 1, and this is negative 6. So we have negative 1 times negative 6. And we end up with negative 5/6, which is not greater than 0. Our next value is x equal to 0, so we have 0 minus 2, 0 plus 2, and 0 minus 3. In our numerator we get negative 2. In our denominator we end up with negative 6, and then this simplifies down to 1/3, which is greater than 0. And then our next value is 2.5, so we have 2.5 minus 2 divided by 2.5 plus 2, and 2.5 minus 3 greater than 0. And then in our numerator we just end up with 0.5, and then in our denominator we have 4.5 times negative, so let me fix that there, negative 0.5. And this simplifies down to negative 2/9, which is not greater than 0. Okay, and then our last one is x equal to 4, so we have 4 minus 2, 4 plus 2, and 4 minus 3 greater than 0. So we have 2 divided by 6 times 1, and again we end up with 1/3, which is greater than 0. So our solution set would then be, going from negative 2 to 2 in union with 3 to positive infinity. Okay, that does it for this video. In the next one we will go over a quick application problem, and that will conclude it for section 8.6. See you next time.